A unit hydrograph is defined for a certain storm duration. In unit hydrograph convolution, the duration of the unit hydrograph must match the interval of definition of the effective storm hydrograph. Thus, in certain cases, it may be necessary to change the duration of the unit hydrograph to match the interval of the hydrograph. Once a unit hydrograph has been derived, a unit hydrograph of another duration can be calculated. There are two methods to change the duration of a unit hydrograph. 1. Superposition method, and 2. Hydrograph method. The superposition method enables the conversion of an x-hour unit hydrograph into an nx-hour unit hydrograph, in which n is an integer. The procedure consists of lagging n x-hour unit hydrographs in time, each for an interval equal to x hours, summing up the ordinates of all hydrographs and dividing the summed ordinates by n to obtain the nx-hour unit hydrograph. The conversion of a 1-hour unit hydrograph to a 2-hour and 3-hour unit hydrographs is illustrated in this table. Column 1 shows the time in hours. Column 2 shows the ordinates of the 1-hour unit hydrograph. Column 3 shows the ordinates of the 1-hour unit hydrograph lagged 1 hour. Column 4 shows the ordinates of the 1-hour unit hydrograph lagged 2 hours. Column 5 shows the ordinates of the 2-hour unit hydrograph, obtained by summing up the ordinates of columns 2 and 3 and dividing the sum by 2. Column 6 shows the ordinates of the 3-hour unit hydrograph, obtained by summing up the ordinates of columns 2, 3, and 4 and dividing the sum by 3. The sum of columns 2, 5, and 6 is the same, indicating that the volume under the unit hydrographs corresponding to 1 unit of runoff has been conserved. The hydrograph method enables the conversion of an x-hour unit hydrograph into a y-hour unit hydrograph, regardless of the ratio between x and y. The procedure consists of the following steps. 1. Determine the x-hour hydrograph by accumulating the unit hydrograph ordinates at intervals equal to x. 2. Lag the x-hour hydrograph by a time equal to y hours. 3. Subtract the ordinates of the 2 previous hydrographs. 4. Multiply the resulting hydrograph ordinates by the ratio x over y to obtain the y-hour unit hydrograph. The conversion of a 2-hour to a 3-hour unit hydrograph, followed by the conversion of the 3-hour to a 2-hour unit hydrograph, is illustrated in this table. Column 1 shows the time in hours. Column 2 shows the 2-hour unit hydrograph. This is the same unit hydrograph calculated in the previous example. Column 3 is the 2-hour hydrograph, obtained by accumulating the ordinates of column 2 at intervals of x equal 2 hours. Column 4 is the hydrograph of column 3 lagged y equal 3 hours. Column 5 is column 3 minus column 4. Column 6 is the product of column 5 times x over y equal 2/3. This column is the 3-hour unit hydrograph. Column 7 is the 3-hour hydrograph, obtained by accumulating column 6 at intervals of x equal 3 hours. Column 8 is the hydrograph of column 7, lagged y equal 2 hours. Column 9 is column 7 minus column 8. Column 10 is the product of column 9 times x over y equal 3/2. This column is the 2-hour unit hydrograph. It is confirmed that column 10 is the same as column 2. The sum of columns 2, 6, and 10 is the same, indicating that the volume under the unit hydrographs corresponding to 1 unit of runoff has been conserved. Note that the S hydrograph is defined only at intervals equal to the unit hydrograph duration. The procedure to calculate a composite or flood hydrograph based on a unit hydrograph and an effective storm hydrograph is referred to as hydrograph convolution. This technique is based on the principles of linearity and superposition. Appropriate multiples of the unit hydrograph are lagged and added to calculate the storm hydrograph corresponding to the effective storm hydrograph. The procedure is illustrated in this table. Column 1 shows the time in hours. Column 2 shows the unit hydrograph ordinates. The headings of columns 3 to 8 show the hourly values of the effective storm hydrograph. Column 3 shows the product of the first hour rainfall depth times the unit hydrograph ordinates of column 2. Column 4 shows the product of the second hour rainfall depth times the unit hydrograph ordinates of column 2, lagged 1 hour with respect to column 3. The computational pattern established for columns 3 and 4 is repeated for columns 5 to 8. Column 9 is obtained by summing across columns 3 to 8. Column 9 is a composite hydrograph for the specified storm pattern. Unit hydrograph convolution is effectively a rainfall runoff transform method, that is, a way of converting effective storm rainfall into flood runoff.